Hey everybody, Corey here with CDS Automotive. Today I just wanted to make a quick video demonstrating the importance of proper signal acquisition and proper techniques to acquire those signals, predominantly when you are working with extremely small, well, any terminal, but extremely small terminals like we have here. So let me explain what we have. I've got a connector that is part of a sub harness, a power steering control module sub harness from a late model Chevy Colorado. And this customer was having multiple issues. There were multiple lights coming on in the dash. They were losing most of the functionality of the vehicle. And ultimately, the vehicle had to be towed to us for us to perform some testing and analysis. So what I had found is there was a couple other issues with the truck, but what I had found is there were two spread female terminals in this connector. And those wires, those terminals specifically were attached to the wires, of course, for the network, which was the communication lines from module to module. And what was happening is it was making and breaking contact. So going down the road, it would lose. I could see a bunch of modules were going offline, and it was just creating a whole mess of problems. So I went in. I've got a new sub harness in the vehicle already, so we're just using this for demonstration purposes. But I went in and depinned 2 pins. Now, as you can see the size, as you can see them compared to the dime. I'll let that focus for a second. Okay, those are pretty small. I mean, they're definitely not the smallest, but we're getting there. They're not extremely large pins. One of these is tensioned properly, and the other one is not tensioned properly. And I don't know about you, but I can't tell with my naked eye which pin is tensioned properly and which one is not. Now, just to give you some perspective, when you look at that inside the connector, this whole top row here has pins in it. And again, I don't know of anyone that would be able to tell if one of those pins had proper tension or not. So that's what we've got going on. Over here, we have a host of, should get it all in there. We have a host of tools that we can use to acquire signals from a circuit. Here up top are the more basic multimeter probes. You know, they're a bit larger. We have a back probing pin. We have the correct sized terminal for correct size male terminal for the female terminal, and then down here we have a couple of piercing probes, which basically has a small needle. You pierce the insulation in the wire, and you acquire a signal. Of course, after everything is said and done, those need to be sealed to protect it against the elements and corrosion and all that. So what I often see is that the correct front probing pin, the male pin in this instance, I often see that this is not typically used when servicing connectors. A lot of times when I see spread terminals, and don't get me wrong, the terminals can be spread just by wear and tear and use and vibration and harnesses not being routed correctly, etc. But a lot of times I see either a meter lead or a lot of times a back probing pin just stuck right in the end. And I mean, you pull on it and there's tension there, of course, because the back probing pin profile is larger than the female terminal. But when this presents a problem, and the black wire with the terminal was properly tensioned, so let me show you something. This one was properly tensioned prior to starting this. I just pulled out 2 for comparison. When you use the correct style pin, see how loose that is. See how much play that has. Okay, so that is a spread pin now. Okay, and the other pin was actually the one on, the original problem on the vehicle when I found this issue. This was the one that had the spread pin, and you can tell there that it's loose as well. See how that you can flex it up and down. There's not a good contact surface on the inside of the pin. Now, it looks a little easier because I had the connector depinned, but when you check, if we were to just go into a wire and say this was hanging down under the vehicle and we're checking something and we just put that back probing pin in there, yeah, I mean, there's tension, of course. Like we said before, the profile of the back probing pin is larger than that of the female terminal. So you pull that out and you hook it back up and you think you're good. Well, no. We want to ensure, see, now we just spread that one as well. There is a little bit of tension on that one, but I'd be willing to bet that if you put that in the vehicle and drove down the road that you're going to have issues. So why is this important? Well, it's important because as shops and technicians, we don't want to induce problems into a customer's vehicle. If we're already chasing an intermittent issue per se, the last thing we want to do is improperly acquire a signal and induce a problem within the connector or the harness or the pins or whatever it may be. And this goes beyond just spread pins. A lot of times with connectors, what I see is, so this, use our back probing pin as a pointer here. This is the primary lock. This is the lock for the connector, okay? And then this white piece up top gets set in after the connector is connected to the component or the other half of the connector or whatever it may be. This is locked to ensure that does not come up and off the little tab that sits in here, okay? And not every connector is the same. I'm just using this one as an example. But a lot of times I see where either the primary tab, you kind of see it bridges there almost on that connector. What I see is those are oftentimes broke. And what'll happen in that case is over time, the connector will sit and wiggle and vibrate due to, just driving the vehicle normally, nothing extreme. And it'll back off enough to where you'll start losing contact with the male pins here on the component side or the other connector side or etc. So with that being said, you now have a failed connector. The connector is no longer being able to be locked. Or I see where these are supposed to be latched after the connector is seated, but I've seen where these will be set in prior to that, and then they just go and push the connector on, and sometimes that can cause this either bridge to break out, or if the connector is brittle or old enough, that whole piece will come out. Now, don't get me wrong, it's plastic. We live in the Midwest. We've got a variety of, weather conditions we put up with. So connectors do get brittle over time. They do break. Weather pack seals, as you can see down there, that blue rubber ring, that's the seal to keep out moisture and debris. We want to make sure those aren't rolled or anything like that, causing moisture or road debris. As you can see, there's already sand and dust and everything else in there that can affect the seating of the connector and the pins. So I thought it was important because, we never, ever want to induce a problem within a customer's vehicle. But I think it's important to realize, knowing when to use each one of these, what's appropriate, what's the least invasive, and what's going to cause our pins to remain tensioned properly if they were prior to testing. We use the right sized pins for front probing, as they call it, and also to perform pin drag tests like I showed you before. Back probing pins are often used to go in behind. Let me show you. So the blue section slides down and locks, but you kind of see there's a membrane back here, an insert, and we can go in behind, make contact with the pin, just touching it, and we can get our signal that way. We don't usually want to put big meter leads down in there. I mean, you can acquire a signal, but we don't want to damage the connector housing or accidentally go through the terminal, even with a back probing pin, and send it out the front and cause a pin tension issue. Piercing probes are fine as long as the holes being left the holes being left are properly sealed up after they're done to ensure that the corrosion doesn't start within the copper wiring and causing an issue further down the line in the future. So I thought that was important. I see it often. We need, great care needs to be taken when performing circuit testing to ensure that, like I said, problems aren't induced. Connectors don't become broke in the process. Again, there are some certain connectors and some certain makes that are susceptible and highly prone to breaking. I typically keep the common stuff on hand because I also see connectors come in where if like the tang's broken out, I've seen connectors RTV'd and pushed together and hoped that they stay. Zip ties through connectors. Like ideally, we want to restore the vehicle to factory condition that either meets those standards or best case scenario exceeds those standards to ensure that the issue doesn't become apparent a year, 2 years, 3 years, whatever it may be down the road. And that was more for the shop owners and the technicians that may be watching this. But like I said, I appreciate your guys' time. I just wanted to bring you along. It was an interesting find, and it's something I find that's very commonly overlooked, and it's becoming more and more prevalent as time goes on, as more modules and wiring and everything gets added to vehicles. It's becoming extremely important. So having the proper tooling, knowing when to do the proper testing, which method to use, of what's appropriate and what's going to get us what we need the least invasive way possible is always the goal. So thanks for watching, guys. We'll catch you on the next one.